Hi everybody, I am here with my new video on matter and energy. Let's start. In this video, we are going to learn about measurements and the metric system. Fundamental quantities in System International. In SI, there are 7 fundamental quantities on which all the measurements are based. They are as following: length, mass, temperature, time, number of particles, electric current, and luminous intensity. Fundamental quantities, definition and unit. Length. Length tells us how much an object is long. Unit meter. 1 meter is equal to 39 inches. Mass. Mass is the amount of matter an object contains. Unit kilogram. Different than weight. 1 kilogram is equal to 2.2 pound. Weight. Weight is a force with which gravity attracts matter. Next fundamental quantity is temperature, which is hotness of an object, unit Kelvin, time, unit seconds, number of particles, 1 mole is equal to 6.02 multiplied by 10 power 23. Electric current measures the flow of electric charge. In SI system, electric charge is a derived quantity that is based on electric current and time. Unit ampere. In SI system, unit of electric charge is coulomb. Luminous intensity measures the brightness of the light. Unit candela. Derived quantities are combination of fundamental quantities. Example, speed. Speed is equal to distance per time or distance divided by time. Other derived quantities are volume and density. The volume of an object is the amount of three-dimensional space the object occupies. SI unit meter cube or cubic meter. 1 liter is equal to 1000 cubic centimeter. 1 milliliter is equal to 1 cubic centimeter. Density. Density measures compactness of a substance and it depends only on the nature of a substance. SI unit kilogram per meter cube. For solid and liquid, gram per meter cube, or for gas, gram per decimeter cube or cubic decimeter. On this slide, there is a table which helps in measurements which are very large or very small. Scientific notation. A number is expressed as a power of 10 and take the following form. M multiplied by 10 power n, where m is equal to mantissa, which is real number. M is equal to or greater than 1 or less than or equal to 10. And here is exponent, which is integer, and it can be positive, negative or 0. To add or subtract, both numbers must have the same exponent. Then mantissas are added or subtracted. Reporting measured quantities. There are some terms that are used while reporting measured quantities. They are as following: accuracy, how well a measurement agrees with an accepted value, and precision describes how well a measuring device can reproduce a measurement. Significant digits. Significant digits are part of any valid measurements and it is direct result of the number of division the measuring device contains. Formula for percent error of measurement: measured value minus accepted value divided by accepted value multiplied by 100. Rules for determining the number of significant digits. All non-zero numbers are significant. Zero located between non-zero numbers are also significant. For example, 101, there are 3 significant digits. For numbers greater than 1 or equal to 1, zeros located at the end of the measurements are significant only if a decimal point is present. For example, 60.0, 0 is significant only when there are decimal point is present. For numbers less than 1, leading zeros are not significant. They merely indicate the number or numbers that follow. Example 0.02. There is only one significant digit, that is number 2. Multiplication and division of measurements. When two measurements are multiplied or divided, the answer should contain as many significant digits as the less precise measurements. For example, when we divide 1.44 by 1.2, the answer is 1.2. Here the less precise measurement is 1.2, which have only two significant digits. So the answer would contain only two significant digits. When we add or subtract two measurements, the answer should contain as many decimal places as the measurement with the smaller number of decimal places. For example, 3.456 plus 4.67, we have two measurements here. And when we add these two measurements, the result is 8.126. Since the measurement with the smaller number of decimal places is 4.67, so which have only three significant digits, and the smaller number of decimal places. So we will round this answer and get 8.13 after rounding. Rounding a number. To round a number, determine the place value you want to round. For example, whole number, nearest tenth or nearest hundredth, etc. Look at the digit to the right of the desired place value. If it is 5 or more than 5, we increase the rounding digit by 1, or if it is less than 5, we round it by keeping the same rounding digit. For example, we have the measurement 5.64, and when we round it by nearest tenth, we look for the digit that is right to 6, and it is 4, which is less than 5, so we keep the rounding digit same. The answer is 5.6. Order of magnitude. A measurement is the power of 10 closest to its value. Example 1, 1284 gram. When we convert it into kilograms, we get 1.284 multiplied by 10 power 3. Here the order of magnitude is 10 power 3. The next example is 8756 gram. When we convert it into kilogram, we get 8.756 multiplied by 10 power 3. Here order of magnitude is 10 power 4 because 8.756 is closest to the 10. Thanks for watching my video. Bye bye for now.